Tonight's speaker, Trevor, you all saw his bio in the email that went out from the university inviting you to join this evening, so I won't requote most of it, but he has also been published numerous times in various magazines and online news area in the area of computer science, including marketwatch.com and in Reader's Digest, specifically on how to make your home internet work better. So tonight we're looking forward to hearing Trevor present to us about his experiences down trying to get a rural municipality to have a better internet and a better connection. I will point out as well that we are also recording the session this evening, and we will be sharing that recording with everyone via our YouTube channel. You can locate the link to our YouTube channel from the Computer Science Alumni website. And I believe also our moderator this evening, Drakshan, has posted instructions on how to find it into the chat. And if she hasn't had a chance to do that yet, I'm sure she will. So please take a look at the Q&A and follow along. And feel free to add your own comments and questions in there. Both she and I will help moderate and pass that info onwards to our speaker as the night progresses. So without further ado, I'd like to hand it over to you, Trevor.
Thanks, Daryl.
Putting your face up there live now.
There we go. Hello, everybody. Welcome. Thank you for coming. Some administrative items before we start. I'll be taking questions as we go, and at the end, if we cover off an item later, I'll let you know. Just so everyone is aware, there is a 15-second delay between when I say something and when the audience sees it. In addition, there will be Drakshan, and if I say her shortened version will be DJ, I'll ask her if there are any questions in the queue periodically throughout the presentation. Because of the delay and because of the moderator, this means it might be a couple of minutes before I hear a question. So please bear with me a moment while I do a quick background administrative item. Great. So a bit about Textor Corp, which is my and my partner's company. Our company, we're both freelance consultants. Freelance just means our clients do not have any obligation to provide us work. They just call us when they need us. This means we work in many diverse situations. Personally, I feel like a Swiss Army knife, having worked doing some of the following things. Sorry about how long it is. Project management, program management, and maintaining a project management office, accounting, business analysis, business development, writing and maintaining legal contracts, negotiating and managing divestitures, microwave and network design, construction and maintenance, engineering and maintenance of communications towers, software development and automation via low-code platforms. I've worked within IT from servers and desktops to data centers. I consulted on internet development with counties and bodies such as the Canadian Association of Petroleum Producers, or CAP, IEEE, and the International Society of Automation. My writings specifically about home internet and Wi-Fi, which seems to be the most popular thing, have been quoted by Reader's Digest, NBC News, Reviews.com, and MarketWatch.com, to name just a few. Our clients are typically nimble businesses looking for a broad skill set at a reasonable price. We are always looking for new clients, so please reach out if you're aware of a possible good fit for us. Now let's introduce the topic. Daryl, could you please present the slides?
Yep, they should be up now.
Okay. So early in my career, I was able to do a lot of different things within IT infrastructure. Software development, databases, servers, firewalls, desktops, you name it, it feels like I did it. And what struck me was how often people blame the network. That got me asking, what is this network thing? How does it work? Is it really the network? And then someone offered me a job in that area, and I've never looked back. Why? I like to contribute in ways that make an impact, and connecting everything seemed to be a good fit. Early on, I figured out just how impactful, as I had my own moments with breaking the network and keeping people out of work for hours and sometimes days. So let's talk about how it all works and where it is going. I'm going to be honest, this is a rework presentation I gave to an Alberta county's councillors. In that situation, the councillors had embraced the fact there's no white knight telecommunications company that is going to provide internet and cellular service to their residents at a reasonable cost, if at all. And they are not the only ones in this pickle. It's a global issue which prompted the United Nations to launch their Broadband Commission to help. You see, the UN understands that the internet is critical to their Millennium Development Goals. So this Alberta county just went ahead and built their own towers, which they own and operate. They brought me to speak to them about what's next. Many of these councillors are farmers, and this definitely put them outside their comfort zone. They appreciated this information, and I hope you do too. So let's dive in. So quick agenda. I hope to explain the overall factors that affect internet globally and in Canada. It's a critical utility. It's wide, easy, and inexpensive access to the internet is a competitive advantage for a country. And really, why not make Canada more awesome? We'll discuss the internet, what it is, how it is an enabler, what is driving its growth, and what it all costs. That is because at the end, I'll present a few emerging trends and options on how to enable internet development despite a poor regulatory environment. This was what was said about railroads in the 1800s. The world grew smaller. It caused surging trade via enabling mail order merchants. It created an outlet for products. It improved public discourse. Communities grew around the rails. It increased rural access to goods and services. It created a more interconnected society. This should sound somewhat familiar to what is being said about the internet. So what is the internet? Well, I feel the analogy of a system of roads fits exceptionally well. So comparing it to roads, packets are just the vehicles that are on the network, and they can be different sizes, just like vehicles can. And how, if they're bigger, they can hold more stuff, and it takes them longer to get there. Routers are basically the traffic lights, the signs, and the policing. The medium, so the medium, and what I mean by that is the fiber, copper, or wireless, is the road. The backbone are the highways, and the internet is like a superhighway. The last mile is like your driveway. So the bandwidth equals the number of lanes that you have on the highway. Latency is the time it takes to travel from point A to point B. Jitter is the variability in latency experienced between points A and B. So in the example displayed, it takes 57 minutes of latency to get from Spirit River to Grand Prairie. If there's an accident on that road and it takes a half an hour more, it'll be an hour and a half that day. So that variation of 30 minutes would be the jitter. Now, sneaker-net, it's the term sneaker-net, it's not used very much today, but it still very much happens, even with today's networks. Sometimes what a sneaker-net is, it's just sometimes faster to transport a data drive to a destination by hand. So there could be a 10 terabytes of data to transport, and somebody might fly that or get couriered to the destination. And that's called the sneaker net. And just like any road, sometimes there's traffic jams and bottlenecks. So this is China's car apocalypse, where 50 lanes goes to just 4 lanes. So you can build a superhighway, and then it gets, the point of it sort of goes away if part of it goes down to 4 lanes. Networks are designed for peak demand, and typically that's been Mother's Day, which is the busiest day of the year, especially telecommunications networks or the phone. DJ, is there any audience questions at this point?
Not at this point.
Okay.
But we encourage them, if you have them, do put them in.
Okay, so broadband is critical infrastructure. It's been declared a utility in Canada. It's at about 2016. It's the United Nations declared it a foundation stone of modern society, and it's so critical to the UN and their Millennium Development Goals that they started the Broadband Commission. The Broadband Commission is a body that helps the world develop internet, and their focus is in rural areas or areas that are hard to get internet to. The expectation around the internet is we are 100% connected. So when an app, what I mean by that is when an app developer develops an app specifically for our smartphones, they expect us to be 100% connected. And if you're a Canadian and you ever leave the city, you know that that's entirely not true. So the folks that live in Silicon Valley live in a little bit of a bubble with respect to what is available to the rest of the world. And unfortunately, those applications don't perform well when the network goes away sometimes. So broadband internet, the basic level of service for homes is 4 megabits. Again, that's our driveway. Using our analogy, that's the driveway. Businesses have a different expectation for broadband. They typically want dedicated lanes, so that's going to be an important factor that I'll bring up again. They're typically connecting their head office to their remote assets, and they don't want to be sharing their road between their head office and their remote assets. The highways or the backbone must be much bigger than to accommodate everyone's driveway being of a certain size. And this is a particular problem in rural areas. So broadband has an economic impact. There's a university study found that doubling a country's broadband speed adds 0.3% to GDP growth. And I calculated what that was in the year that I last wrote this slide, and it's a fairly high value. The UN Broadband Commission tracks each country's funding as a key indicator for broadband support. The funding from the Canadian government compared to what it could yield for our GDP is quite small, as you can see. And I don't believe that's improved or changed very much since I got that figure in 2014. Broadband has a fairly wide impact, and it impacts all 3 pillars of sustainability. And the 3 pillars of sustainability are economic, social, and environmental. Internet access promotes counter-urbanization, also called deurbanization. Environmentally, it benefits by networking up sensors. So it's hard to tune a system of whatever unless everything's talking to each other. Because businesses are the vehicle through which economic development occurs, businesses bring people together and improves their standard of living. Market business news economic development definition is presented on this slide. And they specifically pointed out the internet access separately from infrastructure, which shows how critical it is to businesses operating. DJ, I just wanted to pause again and check if there's any questions.
It looks like we have a shy crowd because nobody's asking any questions.
Okay, I'll ask myself questions at some point. I feel like I'm talking to myself.
Well, actually, I had a question that nobody else
Sure.
asked. Back quite a number of slides, you had arrows. You were talking about the first mile being your driveway, and then businesses having kind of their dedicated road. And there was some numbers on your slide that were like US FCC down, and there was a down arrow 25 megabytes and an up arrow 3 megs. And then there was a different set of numbers beneath that for Canada. What were those arrows trying to tell me?
Those are the upload and download arrows. So typically internet service is not synchronous or asynchronous, as we call it. That just means that whatever you rate you download at, if it's asynchronous or not the same, then those values can be different. And so typically we have been a society that consumes, if you look at our cable TV, which preceded the internet, we were just consumers. It was one way, and that's called download. So typically all these services started out and continue to be this way, that the download's larger than the upload. And that's a problem because we are with the internet, you're contributing. So anytime you contribute, you upload. That should be going away as fiber gets deployed, but then that will depend on where you live and in terms of how fast that might happen. So we'll continue to see download and upload rates being different. Specifically with mobile, they're always, the download is always better than the upload as well. Because
Thanks so much.
Yeah, talk a lot about it for a long time.
There was a comment. There was a comment saying you mean asymmetric, not asynchronous. Is that correct?
I'd have to do some research on that. They could be correct. It's not terms that I use daily. We'll take that offline, and I can get back to them if they'd like. So getting back to the presentation, there's no more questions, right, DJ?
That's right. You can proceed.
Okay, thanks. So the current and future business cases needing ridiculous amounts of bandwidth. So everyone's familiar with residential TV streaming, your Netflix and your YouTubes. Some other things that folks might not consider is video and computer backups. Computer backups have been an issue on the network since the internet was born and continue to be an issue. If nobody backs up their computers, then they probably haven't run into that issue over the network, I should say. Video, I'm splitting out video because there's other video other than residential TV streaming. There's and typically security cameras or cameras that are used as sort of a person. So like in airports, we've got smart cameras that see when people walk into a zone they're not supposed to, and they recognize and send an alert to somebody. For oil and gas, the cameras could monitor a flare stack and see if the flare is not burning anymore. Some cameras can detect gas leaks, stuff like that. So not just security. Big data. What's big data? Well, big data is business cases needing large amounts of data to make decisions. So an example of that is TransAlta told me that if they had big data to constantly tune their wind turbines in southern Alberta, they could yield about 17% electricity generation improvement. So I'm not sure why they do not have enough bandwidth. Typically, a business, if they could yield that much improvement, are able to find the money to build the network. But that's an aside. I could talk about that one for a long time. The other, I've mentioned it before, businesses requiring unshared bandwidth or dedicated lanes. That takes away bandwidth from everybody else, of course, especially if they're sharing over shared mediums like the internet. Telemedicine, so that's remote surgery. So how does remote surgery happen? Typically there's video involved, but there's also robots involved. And my understanding is they need to be fiber connected to have all that stuff work, especially when they're doing surgery. So they're concerned about latency, so how long it takes to get between the doctor and the robotics. And then they would need a lot of bandwidth to make all that work. And telepresence. So I wanted to talk about telepresence, what telepresence is, because it's been around for a long time. However, not many people are familiar with it because it's been prohibitively expensive, which I hope goes away. So telepresence, it's going to be a lot different from your COVID-19 video calls, I really hope it does make it into households eventually, because these COVID-19 calls sure are awkward. I mean, you don't normally talk to a person within a foot of their face. So what telepresence does is it really spoils you from regular video calls. It translates the body language, often missing from regular video calls. The following is a direct quote of a Quora article that better describes telepresence versus video conferencing. In a nutshell, telepresence is a rules-based video experience designed to deliver the illusion that meeting participants in 2 or more sites at completely different locations are in the same room. A video conference doesn't apply any rules, and most of the time people receive a poor quality, unreliable experience when using traditional video conferencing. Cisco pioneered the 20 rules of telepresence so that companies around the world could achieve a better video conferencing experience, resulting in higher usage and increased cost savings over and above what can be achieved with traditional video conferencing. So I was lucky enough to see telepresence in action earlier in my career in the early 2000s. And yeah, it's a lot different from what we traditionally use. DJ, are there any questions after all that stuff that I just discussed?
Still quiet out there.
I'll just throw a comment out for you, Trevor. Your comment about businesses needing a one-to-one dedicated lane is, in my mind, that's kind of like when I'm traveling down Center Street during rush hour traffic and they've blocked off one lane for buses only for HOV. Yeah. And nobody else can use it, and it's annoying because a bus only comes every 5 minutes.
That's right. If we have copious amounts of bandwidth, if we had more lanes than we needed, it wouldn't be an issue. So I'll be talking about that later. But yes, it does come down to sharing resources, and so that's really what we're talking about next, actually. So thanks, Daryl. So what kind of internet growth are we seeing? So Nielsen's law is a law that's been in place, or it's held true since the internet was created, and we've seen a 57 times increase every 10 years. And the wireless capability, which is governed by Cooper's Law, and his law goes back to the beginning of wireless in 1895, we're increasing by 16 times every 10 years. And remember that wireless is the last mile, typically, for most people. I believe the figure is between 60 and 80% of the last mile is wireless. And remember, the last mile is your driveway. So imagine your driveway increasing in size by 16 times every 10 years. And maybe you've been out to Costco and you keep filling that up with stuff and vehicles. Every time it increases, you're like, well, why not just fill it up? So imagine every single person having more capability every 10 years, and then what that's driving on the internet.
We do have a question
Sure.
about telepresence. So what's stopping the adaptation of that?
I believe, well, cost, I think, is the primary factor. The other, I don't know what the figures are now. I know when telepresence costs $100,000 to set up in the mid 2000s, I think that figures down to maybe $10,000 or $20,000. And then you need a lot of bandwidth, typically around 80 megabits. And a lot of companies just don't have that kind of bandwidth. But as we roll out fiber, I think that issue is going to go away. And I hope, I was Googling just a month ago, to see if there was telepresence packages available for at-home folks. But in terms of, unless you're willing to just, use Arduino and build it yourself, there didn't seem to be something reasonable yet. So it hasn't made it to the home. But hopefully that'll change. And what I expect we'll see is home packages that give you little tips on what to change in your room that you set up the telepresence in.
Excellent, thank you.
You're welcome. Okay, so net neutrality. Just wanted to touch on this. What net neutrality is really is a fight over a limited resource. So the idea is we don't have enough lanes to drive in, and the fights over who gets to use what and are we equal. So Bob Kahn, the co-inventor of the IP, called it a slogan. I'm for net neutrality and I'm against it at the same time, because ambulances need to drive through traffic and they need to have what's called priority on the network. So we have something called quality of service that manages that on the network. The internet doesn't have any quality of service, or it shouldn't, and I guess maybe that's what net neutrality is really about. But really what we need and want is an overabundance of bandwidth, and specifically on the last mile, and then this whole issue just disappears. I wanted to discuss oil and gas because we're bombarded by how much Canada's energy sector is hurting and how hard it is to get to market. So Petroleum Development Oman used recommendations from a 2003 IHS CIRA study on a smart oil field. This study was developed here in Calgary. They built a network covering 45,000 square kilometers. At 2013, this network had 130,000 end devices and 13 gigabits total capacity. The network has since had continuous upgrades. The impact of this network is enormous, as you can see from the slide. They paid back this network in 10 months. So my question is, considering the study was developed in Alberta, and we've known about the benefits for nearly 20 years, why haven't we seen a big data smart oil field in Alberta? So considering how far away our markets are and how expensive it is to extract here, this seems absolutely insane. So many of the improvements are limited by broadband access and quality, and then these are the improvements from the CIRA report specifically to the oil and gas business. And as I said, I just want to repeat it, that many of these technologies rely on broadband access and quality. So connected technologies estimated to represent $350 million to $2 billion per company in either savings or increased revenue. So I'm not aware of any smart oil fields in Canada, and I understand that there was a partial one built in Texas for Marathon Oil. So hopefully all this illustrates how better internet in Canada could contribute to Canada's GDP. I know the oil and gas sector, where I've spent a lot of my time, is a big contributor to Canada's GDP. And if you're not sure how much, the top 3 industries in Canada are oil and gas, financial services, and the resource sector in general. Any questions at this point, DJ?
There isn't a question, but there was a comment about a topic that we kind of moved on from, but I'll mention it here.
Sure.
Anonymous said, my understanding is that primary reason for asymmetric home internet today is marketing and business. Also related to why some home routers can have trouble dropping NAT connections with the normal situation of everyone in a household having multiple devices.
Okay. My understanding is the technology, well, you know, cable was always meant to be a download technology because that's where TV was transmitted. DSL, digital subscriber line, with the twisted pair copper, it's just a very small cable. And again, the priorities consumption. Traditionally, those ISPs are also transmitting TV. If everyone had fiber, you could, it would be symmetrical and it would be large. So it's probably a little bit of all those things. Now, NAT's network address translation, I'm not sure how that has anything to do with how many people are in a household. So I'd need to get more information about that. So going back to the presentation, so businesses and remote workers need a stable internet, and I calculated the total cost of ownership of operating without the internet or broadband for a company. So unfortunately, there is a hyper focus on bandwidth. So I just wanted to focus on how much it costs businesses to just lose the internet itself. And this is a really big problem in rural areas. And since Canada is a resource producing country, we're all heavily dependent on rural businesses. So the outage cost to a business depends on their particular business case. But I calculated for an oil and gas site, it would be as little as $15,000 a day. And then one business case was millions of dollars a day when the network depended on the network had to be up for the electricity to be up for the entire region, which is called, there's a technology called direct transfer trip that monitors our electrical grid and automatically shuts off parts of the grid, say if a tree fell on a line. And so that particular instance was millions of dollars a day. And then so I projected this out for a municipality, and I would say it's safe to assume an outage would cost businesses hundreds of thousands of dollars per day. In the COVID era, that's probably not a lot because they're probably losing money hand over fist right now. So examples of humanity's novelties of use. I thought it'd be fun to explore this because of what people say about how maybe that I'm might be exaggerating the usefulness of the internet. I'm not getting that as much today, but I've been talking about this for 10 years and I've got some eye rolling, which is what I believe that they believe to the internet to be a novelty of limited use. So these were all on the slide, were all called novelties of limited use. There was tremendous criticism and pressure to avoid building a sewer system to handle London's great stink. It took several years to get that system built, and nobody wanted to spend the money to make it happen. There was general skepticism about the first automobiles. One banker said to his client, "You're crazy if you think this fool contraption you've been wasting your time on will ever displace the horse." And of course, GPS was invented to help missiles be more accurate. At the time, it was widely thought it didn't have any application beyond that. And of course, with maturity, all these things have become commonplace. And once they become commonplace, you don't even think about them anymore, and of course, until they're broken. Is there any questions, DJ?
Lines look clear.
Okay. So how much does broadband cost? So 70 to 85% of the cost to build the internet is long economic life civil engineering works called passive components. These are things like building towers, digging trenches, building data center buildings, laying cable, etc. And in rural areas, this figure is more like 80 to 95%. So a lot of people think that the internet is just ones and zeros, or that's all it is. Well, most of the cost is in these civil engineering works that have nothing to do with anything powered by electricity. And they have a really long economic life. So in financing, you could use mortgages for them to finance them, just like a house. So tower, I want to talk about towers specifically. So how the tower is engineered itself has a bearing on how much bandwidth it can supply. There's a direct tower weight support capacity, and the bigger the dish, the more bandwidth it supplies. So therefore, wireless bandwidth is contingent on the tower weight support capacity. So it comes down to the internet being a civil engineering issue. So what all this should tell everyone is that if it's difficult to build towers and lay cable, we're going to be in very big trouble. Any questions about that, DJ?
I have one.
Sure.
Do you think that that's going to change as more and more internet usage transitions to satellite instead of on the ground components for that passive stuff?
So satellite capacity is going to be increasing, but the ground infrastructure is going to be increasing that much faster. And it takes 3 years for a satellite to be shot into orbit. So the technology of the satellite's lagging by 3 years because they have to design the satellite with the then current technology, and that process takes 3 years. So wireless is doubling approximately every 2.6 years. So by the time that satellite's shot into orbit, it's already out of date in terms of hardware. So I think satellites part of our communication system, and is a very important part to access hard to reach areas. But it's never gonna, if you can get terrestrial based civil engineering works like cables and towers, you're gonna want those. The cost is just so much cheaper. Satellite will continue to be more expensive. I know that they've got satellites that are the size of shoe boxes and that they're so cheap that they burn up in orbit, but the problem with those technologies is there's hundreds of satellites orbiting in mid-Earth orbit, and you have to buy a $30,000 base station to track all those satellites and hand off properly. So it's complicated, and I don't expect the expense it's still expected to be more expensive than what's available on the ground. Did that answer your question, Daryl?
Sure, thanks.
You're welcome.
And no, there still are no other questions.
So I'd like to quickly touch on the subject of health and wireless, since talking about wireless eventually leads to talking about health. So ionizing radiation, the kind caused by the sun, is of huge concern. So be sure to wear your sunscreen. Wireless is non-ionizing, and the only established hazard of non-ionizing radiation is too much heating, which should make you think of the microwave. So the microwave coincidentally operates on the same frequency as 2.4 gigahertz Wi-Fi. So just as you wouldn't shove your head in a microwave and turn it on, you probably shouldn't put an antenna in your mouth. Should we be concerned about 5G? I think we should, but the question is how much? I think it should be somewhere on the level of a necessary evil, but should we never use a cell phone again? Should we block tower construction and burn towers down like they did in Ireland? Probably not. And as I presented previously, we're going to have constant growth with wireless technology for the foreseeable future. So you'll hear about complaints about 5G in health, and 3 years from now or 6 years from now, probably it'll be 6G and then 7G and so on. Is there any questions, DJ, about health before we move on? I know it's always a hot topic.
Well, there are no questions, but I was just going to make a comment that I'm guilty of sleeping with my cell phone within arm's reach from where I sleep. So what do you suggest the average person do to prevent upsetting our health due to the radiation?
Since your cell phone is a transmitter, I just the power emitted by the transmitter drops off exponentially with distance. So arm's length is probably fine. Mine is an arm's length, usually plus another foot away, so I have to actually stretch. If you talk in terms of talking on cell phones, I suggest using earbuds, preferably wired. If you're going to be talking on the phone a long time, if you just use it occasionally, I wouldn't worry about it. Yeah.
Steve asks, why should we be concerned about 5G?
There's a lot of concern about 5G. There's a lot of funny things going around Facebook with everyone having so much time with COVID at home. They're reading stuff about, there was something said about birds were dying because of 5G, and it turns out that the birds did die around the test site, but it was the wrong day, so they're not sure why the birds die. But of course, it was blamed on 5G. The big concern with 5G is millimeter waves, and millimeter waves are 30 gigahertz to 100 gigahertz. And that technology is used by airport scanners already. There's just not a lot of studies on health with millimeter waves. But like anything we start using more of, there'll be more studies that will result from using that thing. I'm not concerned about millimeter waves. I know the military uses millimeter waves on a crowd suppression system, but the antenna is as big as a house, and probably a lot of power that goes into that.
On a similar strain, Moshe asks, why is 5G demonized? I think you kind of touched on it, but is there anything you have to add?
Well, if you remember back to 2G and 3G and 4G, they were all demonized then. So there's always going to be people that demonize it and say that we're not studying it enough. 5G in specific, there were a group of doctors that started a website to I think put the brakes on 5G. But again, my opinion is that it's really hard to study unless people are using it.
I have one more question. I know the answer to it, but maybe there are others who don't. But if you have a local install and maybe differentiate between residential versus somebody who lives downtown in a condo with other networks, typically you have your regular 2.4G install and a 5G. Which should be used when?
Personally, I use 2.4G for distance. The smaller, the larger the wave, the farther the range, essentially. So as 900 megahertz is a larger wave than 2.4 gigahertz, and 2.4 gigahertz is larger wave than 5.8 gigahertz. I use 2.4 gigahertz in my own household and 5.8 gigahertz to split up the devices over the different wavelengths. In a condo setting, you'll have lots of people nearby that use wireless as well. I think 5.8 gigahertz should work better in an apartment setting just because the range is less, since wireless bleeds into like you can't control where it goes. So you'll have overlapping, what's called overlapping channels. So when you have overlapping channels, it's sort of like everybody building their house on the same plot of land. it's going to get more and more complicated the more people there are. Really, I think folks are just going to have to, if the insistence is on using wireless is going to continue, and we've got overlapping channel, folks are just going to have to get used to installing a frequency scanner on their mobile devices and making sure that they're putting their wireless AP on a non-overlapping channel or a channel that has other people on it that's lower power. I could probably do a presentation about this and show people how to do it.
Of course you could. Just a time check here. We're at almost at 6:30.
Oh, good. Well, I can talk a lot, can I?
Certainly.
Okay, I thought we'd be done. Okay, so we'll move on here to savings. So back to how much the internet costs. I've established that cables and towers make up the majority of the costs. Can we share these things? Yes, and sharing is the primary method for decreasing the cost of the internet, and sharing is the fundamental principle of how the internet was designed. Indeed, this is the main way that cell phone data plans will be reduced, plan prices will be reduced, but more on that later. These are the savings estimates calculated by the UN Broadband Commission for a country. Sharing can be extended from the cables and towers all the way to the actual equipment. Full sharing of all components is called an open access network, and that's exactly what we do not have in Canada. So Canada, this is Canada's sharing status in 2015. The government doesn't think it's important enough to report on wireless infrastructure sharing, so I had to estimate that based on databases that are not intended to figure it out. I estimated that less than 5% of wireless infrastructure is shared in Canada, and then 10% was actually reported on by the CRTC.
Sorry, Trevor, before you get going there, just with the lag, there was still a topic about our last thing we were talking about. Lily asks, I'm told the newer areas in the city have better throughput than the older areas. Is there any way around this? Because I live in an older area.
No, you're stuck waiting for internet service to be upgraded. I've heard some of the older areas are the first ones getting the fiber to the home. And I'm going to touch on that later, why it's good and why it's could be bad.
Lily had
outstructure.
also commented just before that she's getting input errors on her input line and has been told by the service provider that the fix is to reinstall the line, but that it won't happen very soon because currently the company is prioritizing installation in rural areas mandated by the government of Alberta. So does this mean there are parts of Alberta that are not getting internet?
Oh yeah. 40% of rural residents don't have internet, and if they do have rural internet, it can be what I've heard from my field folks is it's worse than dial-up. So if you remember dial-up, I've connected remotely and troubleshot these networks, and I can confirm it is worse than dial-up. You move your mouse and you wait 30 seconds for your mouse cursor to reappear. So the rural areas are in quite bad shape. Should they be in bad shape because there's no infrastructure? I don't believe so, because there's tons of empty infrastructure in Canada, but it's not shared. Anyways, I could probably talk a lot about that. I'll get off my soapbox. Does that answer your question? I think.
I think we're all caught up on the questions.
Okay.
My apologies, I missed Lily's first one. Okay, go on.
Okay, cool. So Canada compared to India shares 6 times less, and cell plan pricing is nearly 4 times more here in Canada. Sharing in India is enabled by tower companies. So tower companies and infrastructure companies, or they're abbreviated as towercos and infracos, is a business model where the company owns the civil engineering asset like a tower or a cable, and they rent it to companies that want to communicate. So that could be businesses typically, or internet service providers. Their tenants would be these businesses, or in the case of a tower, the tenant is essentially the antenna. So as I said, that's very not prevalent in Canada. These companies do exist in Canada, but they don't own very much. There's a stranglehold on Canada's infrastructure by the big three, and I probably could guess who those companies are. But outside of Canada, 70% of the world's nearly 5 million towers at February 2020 are owned by these tower cos and infrastructure cos. This is an emerging business model. It started in 1999, I believe, so it's a very new industry, but it's had explosive growth. Any questions on this, you guys?
There is. I wish Anonymous would say who he is, or he or she is. It might be multiple anonymouses. But the question is, what is the reason for such low percentage of internet sharing in Canada as opposed to other countries? What could Canada do to increase sharing?
I believe it to be regulatory capture, which I'll explain more about later. Well, I guess regulatory capture is essentially the companies that you're regulating sort of control the regulator instead of the regulator benefiting the people. That's my guess. The other issue is so a company like TELUS, Rogers, Bell, in other countries, those companies are getting these towers off their balance sheets because it's recognized that the owning those towers are not their core business. Their core business is getting bandwidth to that phone. And here and by getting the towers off their balance sheet, they're able to invest in that part of their business more. Here, I have a feeling that they continue to own those towers in Canada because it blocks competition. So if you recall, Freedom Mobile tried to get into Canada, and the guy who owned that company just gave up because it was so hard to get ahead here. It's just the environment's just not set up to be friendly for new entrants, and the not sharing this civil engineering infrastructure is a huge barrier to make sure that everybody stays out.
Sorry, Trevor, I'm just going to interrupt you for a second. We have one person who says they're having problems with the audio. I just want to check with the audience if anyone else can just thumbs up or let us know if you're having any audio problems.
And while we're waiting for those thumbs ups to come in, Anonymous says, might want to mention utility co-ops as the solution of choice for rural. Alberta okay. Alberta is plastered with electricity and gas networks because co-ops built them through the 50s, 60s, 70s. In this case, a data utility co-op is needed.
Yep. Yeah. So co-ops, electricity was in it's the exact same position. Like, why would you use this new technology called electricity when you could heat your water with the sun? You know, and lots of residences didn't have electricity, and then of course they had the last mile issue as well. So, but I'll talk more about that later.
Okay. Yeah, we got at least one other person who says the audio is fine. So we're going to just carry on and assume that the problem with Lily's audio is related to the fact that she lives in one of those older neighborhoods where her provider refuses to upgrade her service. Yeah, it's hard to resolve now, but usually the routers have something called quality of service on them. So you should be able to assign each device to how much priority it has for your internet service in your house, if the router is able to do it. Typically the routers provided by the telco, like the TELUS routers bells, don't have that feature. So I'd recommend buying an actual decent router. And if you want to know more about that, go to my website, www.textor.ca. Okay, so how a city municipal network differs from the roads department. So I thought this was a really interesting thing because we used the analogy that the internet is similar to roads and vehicles. So how is operating the internet different from the city's roads department? Well, everybody has to pay the various tolls on the internet. This includes internet service providers, which are the businesses who provide internet service to our homes. Residential service pays these tolls through their monthly internet bill. So what kinds of tolls do we have to pay for? You might have to pay there might be a toll between your home and the internet service provider. And then there might be a toll from the internet service provider maybe to a bigger city, so intercity toll. And then maybe in that big city is where the internet finally connects to the region, and then you pay your internet toll. So there's a lot of different tolls that happen behind the scenes. And this is why Netflix is makes up something like 60% of the internet use, and you can see why everyone was mad, because Netflix's business model wasn't paying for all these tolls. So there's been a lot of, I think since everyone got mad at Netflix about 5 years ago, and Netflix has been installing some of its own cables, not necessarily cables, but renting cables between major centers and installing content devices closer to the folks that are consuming the video. So what's also different from the roads department is the growth in the internet and that sort of technology. The growth is just massive, as we talked about with the Nielsen's and Cooper's Law. We have a bit of Wild West situation happening because this area is sort of new. We've had roads and cars for a long time, and that's now established. Well, with this
you have sort of your Wild West. So the technology continuously changes. There's not a lot of policies, and then the laws are still evolving, stuff like that. So it's more like managing a mega city. So if you're the small municipality and you got 6,000 people, all of a sudden you create your own set of towers. You're all of a sudden managing this mega city. So it brings a lot of complexity. So I predict and I hope we'll see cities and counties have their sort of own roads department but for the internet. DJ, is there any questions? And I should preface that City of Calgary has its own network, which I'll touch on later.
Looks clear.
Okay.
Oh, hold on. I see a new comment. Okay, so let me just publish it first and then go back and read it. Apologies if this is beyond the scope of your lecture. The negligence of our government is a travesty. How can we advocate for more utilities sharing? Who needs to get poked with the pitchforks first?
I've been working on that for many years. It's technically complicated. I have talked to the Service Alberta folks about some of this stuff. So yeah, it's outside of my wheelhouse. I'm not a politician. So if anybody has any ideas, I would love to talk to people about it.
Thank you.
Okay, so long term, I expect the sharing to increase, but here in Canada, I expect it to increase very slowly. Canada is lagging the global trends. Because rural is affected by progressive trends last, the only viable option for rural areas seems to be to do it themselves, either via the municipality, utility co-op, or a mix of the two, specifically for cables and towers. So the utility co-ops, we already have utility co-ops in a lot of these municipalities that do gas and or electricity. I don't think it would be much of a stretch for them to take on internet. However, remember these co-ops, they've been operating in very established areas that haven't experienced a lot of change for close to 100 years. So I've seen issues with the co-op doing it. You have to have some really forward-thinking leadership. So either of those two or a mix of the municipality and the utility to help build out that passive infrastructure. So the big problem is the cables and the towers. So if they can figure out how to make that happen, a lot of the other stuff, they might be able to partner with businesses to provide. So ideally, we could trust the government to implement a supporting regulatory environment, but I suspect that Canada experiences regulatory capture with respect to internet in Canada. So I mentioned it before, but I'll read the definition. The definition of regulatory capture is the economic theory that says regulatory agencies may come to be dominated by the industries or interests they are charged with regulating. Result is that an agency charged with acting in public interest instead acts in a way that benefits the industry it is supposed to be regulating. And you've seen this recently with Boeing and the FCC, I think, right? However, we do not need to rely on the government. There are many creative balance sheet strategies to enable internet growth. So utilities, so for the last mile installation of cables, the construction cost can be made to be part of a customer utility package contract. In cities, this might be how we get fiber to the home. Fiber is the only cable type that allows for infinite bandwidth growth, and soon all cable types will be fiber. Ideally, this cable is owned by a utility or non-telecom company to promote competition. So the only company that's rolling out fiber in Calgary is TELUS, and that fiber is owned by TELUS. I see an issue with that. Now you have to, so instead of that being owned by a company that willingly wants to rent out the fiber, we have to have a regulatory agency come in and tell TELUS to share, which is not an ideal situation, in my opinion. If it's owned by a company that's really eager to rent out that piece of asset to anybody and anybody, things just are a lot more smooth and easier to happen. So just to give you an idea, I wanted to co-locate towers for or co-locate antennas on TELUS towers in northern BC, and I represented a business, so I was not competing with TELUS. It still took 2 years to ask and be approved to put the antennas on that tower for something that should take 6 weeks total. And that was, I had to complain a lot. I had to escalate. I didn't make it to the point of filing a CRTC to get a decision made, but this is essentially how the Freedom Mobile had so much problems. It's really hard to build a business when you're always having to go to CRTC to complain about how long these things are taking. And that's all the TELUS, Rogers, and Bells have to do. They just drag their feet. So they're sharing, but they don't have to be fast about it. And then, well, because it's taking a long time, all these competing businesses run out of money. So that's how that happens. So with this infrastructure and building it, the infrastructures and tower companies, these tower cos, they're interested in building these towers for us. But so what you do is the community groups or the local governments can prove demand with end customers, and this can be done by aggregating demand via legal documents called expressions of interest. So essentially, a customer says, "Sure, I'll pay for $100 internet package as long as you build this stuff." I'll sign a thing saying that I'll hook that up. And then they aggregate that demand and they can do their revenue models and see if they can build that infrastructure. And because they're motivated to get that up and running as soon as possible, it'd be like building a commercial building. They get that built pretty fast once you have that expression of interest or aggregated demand proven and in place, because they have to use that to go to the bank to get mortgages. Cities and municipality, which work for us, the taxpayers, should have a dig once policy. This means whenever a trench is opened, put fiber in it. This can directly reduce overall internet costs for all citizens. Typically, infrastructure companies, are basically the fiber companies that rent fiber, offer to reduce fiber installation costs if the municipality allows them to install their own conduit and or fiber when there's an open trench. So essentially, this is a real estate game, and they are looking to acquire real estate at an inexpensive price. So the cost of laying fiber is opening the trench. It's not the fiber itself or the conduit. Cities and municipalities have the option to rent dark fiber or duct space to businesses, which can lower costs for both parties. Dark fiber is a cable with no electronic components on it. It isn't lit up with light, so it's dark. Since fiber can offer unlimited bandwidth, a company just changes the electronics to get an upgrade. There is no increase in monthly costs. So to give you an example, you might have rented dark fiber between your business and a data center, and you have 100 megabits, and maybe you rent that dark fiber for $1,000 a month. Well, say you want to upgrade that from 100 megabit to 10 gigabit or a ridiculous amount of bandwidth. Well, you just pay one-time cost to change the transceivers, and voila, you've got 10 gigabits. And does your monthly cost go up? No, you're just renting that dark fiber. So it's really as much bandwidth as you want, and you don't have operations costs that go up. I wanted to talk about the City of Calgary fiber case study, which I think is a really interesting story that not many people know about. So originally, City of Calgary had its own dark fiber network. This was in the 90s, and they and this was a dark fiber network that they allowed to be rented to businesses. So the business I was at rented this dark fiber. So what the City of Calgary did with this dark fiber network was they privatized it via putting it into NMAX. And NMAX sold this fiber network to Shaw, who shut it down since it's more profitable to sell managed services. So imagine a customer goes from 100 megabit and they're paying $2,500 a month, which is about what 100 megabits costs. And they go to 10 gigabit. Well, that's $5,000 a month. So you can see that Shaw, TELUS, Rogers would profit from what's called these managed services. So they don't want dark fiber networks. So what did Shaw do when they got this dark fiber network from the City of Calgary? They allowed businesses that were already on it to be grandfathered and keep their dark fiber rentals, but they shut it down to new businesses. So City of Calgary was stuck because they needed services. They still needed to connect new communities. So the City of Calgary uses their dark fiber to connect up their various facilities, and they connect up their street. You'll see the cameras on the street lights. All that stuff needs to get connected. And so the City of Calgary deemed it a critical service. So they're building another dark fiber network now. As of about 5 years ago, they started rebuilding their fiber network from scratch. This new fiber network is using technically advanced fiber cables that have 600 strands per cable. You can go up to 1,000 strands per cable, and they're renting out each strand for $1,000 a month per strand to any point B in Calgary. The Shaw equivalent, if you were able to rent it anymore, would have been $3,500 approximately, and it could be more because it's based on distance. The City of Calgary is also allowing businesses to so typically the dark fiber network's not connected to each business's building, so that's called. So we got to connect the last mile. Well, the City of Calgary is asking for a loan from the business, so the business loans money to the City of Calgary to build that last mile for the business to connect them up, and then the City of Calgary reduces that $1,000 a month by 90%, so $100 a month, until the City of Calgary's paid back the loan to build the last mile. So that was it for the interesting case study. That's it for my presentation. Thank you for your time. Are there any questions?
There's just a few comments in here about encouraging people to relentlessly poke your MLA, your elected official, to try and get some change on some of these decisions about shared infrastructure, and a few comments about some places like Olds, Alberta has gone ahead and built their own fiber utility.
Yep.
But no questions. But that doesn't mean that people can't pose them. I have about 6 minutes to the top of the hour, which was our estimated end time. And if there's people out there that want to either pose questions or share in the discussion, we are happy to relay whatever comments you have for everyone to hear.
You mentioned Olds, so I got interesting thing to say about Olds. Now, Olds is trumpeted as a great case study. Well, I talked to Lance, who built the Olds fiber network, and I asked him a key question: would you ever do it again? And he said, hell no, it was the worst experience ever. So I imagine he encountered a ton of resistance. So I don't think that the environment's set up for that to happen easily. So Olds is great, but can we repeat it? I think it takes the community to band together and say that this is something important to them for it to happen. I'd say that would make it a lot easier. Any other questions or comments?
Seamus would like to know what your highest priority going forward would be.
Highest priority to encourage internet building? I'm assuming.
I'm assuming too.
Well, I built my own internet networks in rural areas since I'm an engineer as well. I guess you could consider me an engineer, even though I've got a computer science degree. I consider us all engineers anyways. And building those networks, there's no sort of marketplace to go to figure out where everything is on a map and connect it all together. And I think that's a really easy thing for the government to do, is to create a marketplace online, like eBay or whatever, for building internet. So it's incredibly difficult to build something rurally right now because none of it's published. In the US, they have a database of towers that are over 100 feet high. So you can go, there's a public database, you can look where everything is to build out a network, but only for towers that are 100 feet high or higher, which still eliminates a lot. Well, in comparison in Canada, what database do we have? We don't have one. So I think it's crazy. We spent 350 million, it looked like, in 2014 on internet development for rural areas, but yet we don't have a marketplace. I guess this is what happens when you have politicians do things.
There's another question.
Regulatory capture probably is a problem. Sorry, go ahead.
What role do citizens need to be playing, asks Seamus.
I guess spreading the message that there's an easier way and it doesn't necessarily cost us any money. If folks can take what they learned from this presentation and spread the word, it would be great. I tried to broach this subject with openmedia.ca, which is a not-for-profit that does support this kind of stuff, but they're trying to get, their focus is very narrow, and I think my focus is more about education and more of like rehauling the system rather than open media is trying to go for. They're trying to get with the mobile network operators. That's not the right term, but there are these, those cards that you get in other countries where you could buy a prepaid, you could get a cell phone number temporarily from a vending machine or whatever, and it will use another network like TELUS or Rogers underneath. I can't remember what they're called, but that's what they're trying to get done. And I don't think that solves the problem of getting copious amounts of bandwidth to everybody. I think that's a pretty narrow focus. I don't think that's going to improve many people's lives a lot. And I'd be interested to hear if anybody has any ideas. I have a young family, so I don't have a lot of time to go out and hit the pavement and politic this
Go
stuff.
door to door with give a petition for people to sign.
Yeah, plus my running my own business, and so doesn't leave a lot of extra time.
Trevor, on a lighter note, what is this picture representing? A deflated raft or something?
No, that's a towel.
That's a towel. Oh, okay. All right. I'm seeing a smaller version of it.
Yeah. It's screen size, right? We're all at home and we all have different screen sizes.
Well, I've got the multiple views, so.
Well, speaking of time, we're right at 7 o'clock. I don't know if anybody else has any last questions they want to post, but if anyone in the audience is feeling like this is the time I agreed to be here and I need to leave, we have officially gotten to the end of Trevor's slides, and I want to just take a quick second to say thank you to him really quickly, and deeply appreciate all the time and effort that you put into not only preparing the slides, but also getting ready to do this presentation with us this evening. I know we rehearsed a few times because we were all new at this Microsoft Teams live event thing, and welcome any other last questions or comments. And I will remind everyone that we will be taking the recording from tonight, and I'll hand it off to our videographer, who will do a little editing and possibly cleanup of the sound quality, or if anything else that he can do. And we'll get it out onto our YouTube channel sometime in the next few, I want to say days, but maybe week.
Well, that's why I covered my bases with the very near future.
Yes, we're all new to the new
Lots of
COVID.
People posting that they're thanking you for your time and saying that it was a great presentation too. I hope you have a few minutes later today, or when we get the stats back, to review some of those kudos to you, Trevor, that have been coming in.
Well, thank you. And thanks for everybody for coming and listening to what I have to say and what I've learned throughout the years. We appreciate your guys' time.
Thank you, Trevor. Sincerely.
All right. Well, I'm not seeing a lot of questions in the chat or in the queue of things, so I'm going to say last call for questions, and if I don't hear any or see any posted in the next few minutes, then I'll probably disconnect everybody. We'll give you 2 more minutes to post questions, and if we don't see any, thanks for coming out tonight. If you do, however long Trevor's willing to stick around, I'm willing to click push and let those questions be visible for us to pose to him.
And this is your opportunity to ask about home internet and placement of router and what router to buy and why not use your telecom router provided by your provider, that sort of thing.
I've seen a lot of advertisements lately, Trevor, for Wi-Fi repeaters, so that you know, if you have a dead spot in your house or something, that you can get a repeater and have the signal be boosted. Are they good devices? Is that something that's worth having?
Well, us old time wireless guys that have been doing it for a long time avoid repeaters like the plague. So if you can get away without using a repeater, I would recommend doing that. I myself have my router is 6 years old and it still has the farthest range on the market. So my signal goes through 8-inch concrete retaining wall all the way out to my alleyway, and I still get signal back there.
So I'll be honest, I bought one, but I didn't buy it for my house. I bought it so I could throw it in a suitcase, and when I get into some hotel where the room is too far from the lobby,
yes,
works
I have
like a charm there.
Yeah.
There's a question. There's a question. I know what Trevor's going to say. He's been bugging me about this for 2 years, saying I need one of these. But there's a question asking, what is a recommended current model for a home Wi-Fi router?
So I use the I'm just gonna have to make sure I'm
The
saying the
Nighthawk.
model, correct model here.
Nighthawk?
And pretty sure it's the Nighthawk R8000. I'll just double check. Nighthawk R8000. Yes, made by Netgear. They still sell it on Amazon.ca, although it is starting to age.
You can also get it at Costco, guys. Not Canadian Costco, American Costco. Let me rephrase.
It is. It's been on the market for 6 years. I've never seen technology on the market this long, and not get changed. And the wireless is only 802.11 AC. We're at 802.11 AC Wave 2 for anybody who's keeping score. But if you go to texter.ca, I've got an article about forget a bandwidth upgrade, improve all your stuff at home. I can't remember the name of the article. You should be able to have a crappy 20 megabit download, 5 megabit upload, as long as all your home infrastructure is really, really good. Includes your computers.
You said Nighthawk R9000?
R is in Ralph, 8000.
8,000.
Yeah.
Okay.
Yes.
Because there's a 9,000 out there on the internet if you Google it. But all right.
Yeah, there's higher level models. Yeah, but this is the one with the best range. That I can't remember what they changed with the higher level models, but it comes with the thing you want in a router is it's got to be heavy, and it's got to have as many antennas as possible, and preferably those antennas are external antennas, not internal antennas, and the thing is ugly as utterly possible. So DJ
and you can kill somebody with it because it weighs 5 pounds.
Exactly. Remember, a router is a PC that its purpose is to route traffic, so make traffic decisions, and you need weight. Like the heavier a computer, the more it can do. So you want that router to make decisions as fast as possible. So the cheaper you go, the lighter it is, and the less fast it goes. And if you get it free from the telco, it's of course the most inexpensive piece of junk that they push on the masses. I mean, because you're getting what you paid for, which is free. So I'd recommend getting rid of it. Or you don't get rid of it, you converted that telco router into just a modem, and then you connect to your router. Essentially what happens.
Well, I don't see any more questions, and we're down to 18 attendees on the line. So about a third or so of our peak attendees have dropped off. So I think we're done, and I'm going to end the presentation. Thanks again for everyone who joined us this evening, and also thank you to the one person who did post a suggestion for a future topic. They said COVID-19 tracking apps being talked about, what the security of these systems might be is an interesting topic suggestion. So we'll look into that and see if we can find someone a little bit in the expert realm of that. Thanks again, everyone, and I hope you enjoyed tonight's presentation, and we'll look forward to hopefully seeing you in person someday and maybe at another one of these remote events in the meantime. Bye-bye.
Bye, everyone.
Bye-bye, everybody.